I'm going to draw a little picture to start out on this problem. So I have a rectangular field. I'm sorry, that doesn't look much like a rectangle. And I have a pavement around the field, and the goal of the problem is to find the width of the walk. And so what I'm going to do is I'm going to make that my variable. I'm going to say let x be the width of the field. Oh, the width of the pavement, sorry. So I'm going to also label that in my diagram. I'm going to call this x. That means the width everywhere is x, right? The width here is x, the width here is x, and the width here is also x. I'm sorry, this is bothering me a little. I should redo that. Okay, there we go. Now, what are the other things that we know about this rectangular path? The other things that I know is that I know that the area of the entire pavement is 768 square feet. That means, well, this entire part, I'm going to roughly color it. I know that the area here is 768 square feet. I also know that there's a fence on the outer side of the pavement, so that's this outer part of the pavement, and the dimensions of which are 60 feet, so the longer side is 60 feet, and the shorter side is 44 feet. Okay, that's all the information I have, and I need to figure out what this width is. So let's write down a few more things. So one thing to note here is that if this entire side is 60 feet, and if this width is x and this width is x, it already tells me that this length is 60 minus twice x, since I'll be taking the entire length 60 and subtracting x twice, so that's 60 minus twice x. And similarly, if you have to look at the length of the shorter side of the inner field, it's going to be 44, that's this whole side, minus x, so that's 44 minus 2x. One additional thing that I know is if you look at the area of the entire thing, the entire big rectangle, the area is going to be 60 times 44, since that's the area of a rectangle is the length times the breadth, and 60 times 44 is equal to 2640 square feet. Okay, let's write all this down systematically. So I know that the area of the outer rectangle is the length times the width of the rectangle, which is equal to 60 times 44, which is 2640 square feet. Now, I don't exactly know the area of the inner rectangle, but I do know that the length of the inner rectangle, I know this in terms of x, is 60 minus 2x, and the width of the inner rectangle I know is 44 minus 2x, which means that I can also somehow say what the area is of the inner rectangle. By the way, why am I calling this the inner rectangle? This is just the field. The area of the inner rectangle is the length times the width, so that's 60 minus 2x times 44 minus 2x. Okay, we need to find a way to put all of this together. How does this all come together? Let's see, I've used up 60 feet by 44 feet. The only thing that I haven't used yet is the fact that the area of the pavement is 768 square feet, so I'm going to use that next. Now what I know is that if I need to find the area of the blue shaded part, it's just going to be the area of the outer rectangle minus the area of the inner rectangle. So let's write that down here. I know that the area of the outer rectangle minus the area of the inner rectangle is equal to the area of the pavement. And I know all of these areas in one way or the other. The area of the outer rectangle is 2640. The area of the inner rectangle is 60 minus 2x times 44 minus 2x. And the area of the pavement is 768. This is great because now this is my equation that I just need to solve in order to find x, which will give me the width. Okay, so let's start by taking off the parentheses. So I'm going to write 2640, and in order to simplify this part, I'm going to FOIL it out. So what I'm going to do is initially I'm just going to retain the negative sign and write this all inside a big bracket to avoid confusion. So 60 times 44 is 2640, and then outer, so 60 times 2x is negative 120x. Inner, so 2x times 44 is negative 88x. And finally, negative 2x times negative 2x is positive 4x squared equals 768. Now, since I have a negative sign here, I'm going to be very careful about that negative sign as I distribute it inside. So this will have a negative sign, the negative signs inside turn to positive signs, and the positive ones turn to negative. So now my equation becomes 2640 minus 2640 plus 120x plus 88x minus 4x squared equals 768. I can simplify some of these terms. 2640 cancels out. 120x plus 88x is 208x minus 4x squared equals 768. To solve this quadratic equation, I'm going to take all the terms onto the same side. In order to do that, I will add 4x squared to both sides of the equation. And since 208x is added, I'm going to subtract 208x from both sides of the equations. This means I can cancel them from the left hand side, and my equation now becomes 0 equals 4x squared minus 208x plus 768. Of course, conventionally we like to write this equation as 4x squared minus 208x plus 768 equals 0. Of course, you can use the quadratic formula to solve this equation, but I prefer to look at all the numbers and try and see if I can reduce the equation somehow. So you'll see that they all have a factor of 4. So I'm going to divide the entire equation by 4, which now gives me x squared, and if I divide 208 by 4, I get, I want to say 52x, and when I divide 768 by 4, I get 192 equals 0. This is great because now I have a quadratic equation that has coefficient 1. Either you can solve this again by using the quadratic formula, or I'm going to solve this by using factoring. So I need to find two numbers which when multiplied give me 192 and which when added give me 52 or negative 52. That's going to be hard. So let's see. After working out some of the calculations and trying out some numbers, I come to the conclusion that it's 4 times 48. But since I need a negative 52, what I'm really looking for is negative 4 times negative 48, since when I add up those two numbers, I get 52. So that means that the factoring of this expression gives me x minus 4 times x minus 48 equals 0. So I have two possibilities. X minus 4 equals 0 or x minus 48 equals 0. And that tells me that either x is equal to 4 or x is equal to 48. Now it looks like there's two possibilities for x. X is either 4 or x is 48. But let's go back to the picture and see that the inner dimensions for the field were 60 minus 2x and 44 minus 2x. And what you'll see is that if x were 48, then what happens is that the length of the field will be 60 minus twice of 48. That's 60 minus 92, which will be negative 32. So that's obviously not a solution since length of a field cannot be negative. So that means that I cannot accept x equals 48. The only answer that I can accept is x equals 4. And that tells me that the solution to this problem is the x equals 4, or the width of the walk is 4 feet.